So important XML files that we need to be aware of are your Hadoop PNV, your core site XML, your HDFS, MapRed site XML, and in our case with Hadoop 2, we have done with Yarn site XML. So if you are primarily an administrator, that is where these XML files are very, very important for you. Where the masters, okay, there will be a masters file with Hadoop 1, which will indicate what are the secondary name nodes, and there will be a slaves file, okay, and in the slaves file, I think if you have done the installation through the steps we have given you, you have a slaves file where in the slaves file you will enter the IP addresses of each of the slave nodes, right? Core site XML contains properties relevant to the entire cluster. Then it also contains your, see, we talked about checkpointing, right? So everything can go here. I mean, typically, it should also be into your HDFS site XML. So your DFS name, your DFS data directory, all these properties relevant to your DFS, your HDFS, will go inside your HDFS site XML. So your replication factor, your block size, these are the properties which are relevant to your HDFS. So you would have them in your HDFS site XML. Then the GUI tools, right? So GUI tools, your name node is accessible on 50070. Then your job tracker runs on 50030. Your task tracker on 50060. Then your block scanner report. This block scanner report will help you to see what are the blocks available. Okay, and with Hadoop 2, you need to talk about Yarn, right? So your Yarn UI will be accessible on port number. What port, guys? I think I showed you this port, right? 8088. Okay, so your Yarn is available on your port 8088. So these ports are default ports. So having them handy, I mean, these port numbers, sometimes you might get an interview question on what these port numbers are. It is helpful. Okay, so maybe let's see about anatomy of read and write. I don't think we have seen this, right? We have not talked about anatomy of a read and write, how the read happens or the write will happen. So maybe let me quickly go through this. I have a nice diagram here talking about it. So when the client says you want to read a file, okay, just give me 1 second, guys. Sai is asking, these port numbers doesn't change for the daemons. See, what happens here is when you're accessing any port number, okay, let me try to quickly show you on this instance. This is the Cloudera installation. Where I have everything up and running. So this is how your Cloudera cluster would look like. Okay, your Cloudera manager installation via your Cloudera manager. Now, the ports that we are talking about. Okay, let me drag this out. The HDFS, right? So HDFS, if you say name node UI, so this is a port number. My name node is running on. See, it is running on the port 8020, okay, and this is running on port 50070. So there's a slight difference here. So what happens is for each of the daemons that you start as part of your Hadoop cluster, there will be one, okay, not for each, for major, for your name node, data node, job tracker, task tracker, resource manager, your node manager, there will be one web server running in the background. Okay, for these daemons, there will be a web server running. So it is common to almost entire Hadoop where you'll have a small JSP page which runs. So this JSP page runs on port 50070. But the actual daemon, the name node daemon, is running on port 8020, right? So this is for your TCP/IP communication, where you want to see what is happening on this user interface. Now, this is for your RPC communication between the nodes. This port number which you define in your core site XML, in your HDFS site XML, and all, right? So this port number is the one which will be used for our RPC communication between the data node daemon and the name node, between the job tracker and the name node, between the task tracker and the data nodes. So these are the ports required here. So these two different ports you need to distinguish. And just the web interfaces is what the default ports you need to understand. This port can be anything. The web interface port is always default. So you can change it. You have the ability to change it, but they have already preset these port numbers. And if you do not call out that property, then it will be your default port number will be applicable here. So that is your name node UI. Then you go to Yarn, your Yarn web interface. Okay, so this runs on 8088. Then your Yarn history web server. Okay, which runs on 19888. So these are all the default ports. Okay, which shows you what are all the programs that have run on your cluster. Now, let's see what is a read. How does a read happen and how does a write happen? Okay, so first of all, let's talk about a read. Okay, let's say I have a 100 MB file on my HDFS cluster. I want to read the file. Okay, so what is that I do when I want to read the file? You are a client machine. Okay, from the client machine. Okay, you're from the client machine. You invoke a read operation. So how do you invoke a read operation? You execute your Hadoop commands, right? You say Hadoop fs-ls, and then you give the file name. So file name, it goes via your Hadoop APIs, okay, your Hadoop DFS, right? Because typically you're trying to read your FS, your file system, your distributed file system packages. It goes via this, and from here, from this API, the request goes into the name node. Now, the name node will have the metadata information here. So you are sending in the file name and says, this is the file name. Can you give me where this file is located? Okay, where are the blocks available? So the name node will query its metadata. Hey guys, let me keep this close to me. Okay, the volume is good. Why is this fluctuating? Okay. Yeah, I think that would be better, Daniel. Just give me a call on my mobile. I think there's some problem with this phone, with this headset. Yeah, the attendee ID would be 2987.
Yeah, Kumar?
Yes. Hey guys, I hope this is better then. Is this any better now? Okay. So, all right, yeah. Now, when the read happens, when the user says you want to read a file, he would be submitting, the user would be submitting his request via the API, and the API would go into the name node, and the name node will query its metadata, see what is the file name, where are the blocks available, and gives that location into the your client machine. Now, on the client machine, what will happen? There will be an input stream open, because the client will get this information. The client will say, okay, here are the nodes, here are the data nodes, list of nodes where this file is available. So in this case, I have a 100 MB file. This 100 MB file is available on two different nodes. One is a 64 MB and the second one is a 36 MB block. So it is available on two different nodes. So it will contact your, it will invoke and there will be an input stream opened up. Okay, similar to your, let's say, this is something similar to your database. When you're reading your database, you program, right? So what you do, you first of all open the file. Okay, for example, any file you are opening from a Java program or anything, you open the file, you read the content of the file, and then you close the file. The same analogy applies here. There will be an open stream happening. Okay, an input stream will be opened up, and it will try to open those many streams as many blocks are available. Because my file is made up of two blocks, two streams will be opened up, and both of them would be reading the blocks simultaneously. So when they read the blocks simultaneously, the 64 MB block is read from one node and your 36 MB block is read from the second node. Together, they will become your file, and this message is given back to the client here. And once this is complete, okay, when this is complete, the input stream, whatever it has opened up, this will be closed, and you'll mark the transaction as closed there. So this is how this read happens. So read is very simple, and important point to understand here is that any initial communication will always go to the name node. Okay, the first request communication will go to the name node, and the subsequent request to actually gather the data will be going into the data nodes. Now, this is a way talking about how to read. So, client, this is actually right. I think I need to maximize this, show it in a presentation mode. So how you want to read a file? Okay, when you want to write a file. So what will happen? So you have your data here, you have a name node, and you have multiple slave nodes here. Now, client sends a request to the name node to add a file to HDFS. Right? So you are wanting to write a file. So what will happen is the request will go to the name node. The name node gives client a least to the file path. That means because the data nodes will give a heartbeat message every 3 seconds to the name node. Name node will have a list of all the data nodes which are all available at any point of time. So that with that information, it will query its metadata and sees that these are the data nodes available. Okay, you can go ahead and write into these nodes. Okay. Now, once this information is with the client machine, for every block, the client will request the name node to provide a new block ID and a list of destination data nodes. Right. So for every block that you have here, the client will request the name node, okay, to provide a new block ID and a list of destinations. So you have blocks here. So first block, the client will write the block directly to the first data node in the list. All right. So this is what the client will directly go and talk to the data node and write the block here. Now, the first data node pipelines the replication to the next data node in the list. So we have written the block, but we also have a replication factor of 3. Right? We also have a replication factor of 3. So replication has to be done. So as the block is getting filled in here, this will go into the second data. It will contact the second data node and says, get ready to accept this block. So this will be writing into the second data node. And as the data is getting filled in here, it will contact the third data node and says, okay, get ready to write into this block. So this will be written in here. Now once the data written is complete, the replication part is complete, you should be getting in. So I think this is not complete, guys. So I mean, basically, okay, let me finish this. So this is how the replication is all done. Okay. Now if you see how the data integrity happens, okay, how the data integrity while writing is happening, right? So the client is contacting the name node. I want to write a block. Okay, please use nodes 1, 4, and 12. Then the data plus checksum will be what sent. Okay, the blocks, right, will be sent to the data node 1. Data node 1 will write into the data node 4 and also into the 12. So that is your replication is happening here. Now the next thing is the replication happens to the third node. The third node will send a heartbeat message to the second node indicating, that is data node 4, the write is successful. The second node, which is data node 4, will send a heartbeat message to the data node 1 indicating the write is successful. It's an acknowledgement. An acknowledgement is sent back saying this is write is successful. When the first node gets the acknowledgement, it gives back an acknowledgement to the client machine indicating this write is successful. So this is happening for a single block. Okay, this entire sequence is for only one block. Now if you have multiple blocks, okay, if you have multiple blocks, the same thing will be applied for each and every block. Okay, if you have 100 blocks, so there will be 100 write streams happening. So for each of the block, name node will make an entry. Name node will decide where this block has to go and reside. Okay, so for each of the block, it will be this same process will repeat. So now one observation you could have made is write will be parallel. Okay, write is parallel. So the write will be parallelly happening. In my case, it's a 100 MB file. So 64 MB is a write sequence happening for 64 MB. And simultaneously, a parallel operation will also be happening on a 36 MB file. Okay, so write is parallel and replication is what? Can you guys tell me now? Write is parallel. Replication is, how did the replication happen? Yeah, it is sequential. Okay, it is sequential. So write is parallel, replication is sequential. It is always the case with Hadoop. When you talk about write, okay, so when you're writing the data, write is parallel and replication is sequential. When you talk about read operation is completely a parallel operation. All the blocks are read together, combined together, and given to you, displayed to you on the screen or to your standard output. Okay, so very, very important. Write is parallel and replication is sequential. Replication is also called as a pipelined, pipelined write. Okay, it is called as a data pipeline. Why is because just imagine this, visualize this as a pipeline, okay, holding water. So name node decides, yes, Jay, let me finish this pipeline, I'll come to that. So it is called as a pipeline because as this water gets filled into this pipeline, then only it will trickle down to the second pipeline. As the water gets filled into the second pipeline, then only it will trickle down to the final pipeline. So that is why it's called as a data pipeline. Now, another question that Jay is asking is, name node decides the data nodes. That's right. Exactly, Jay. So name nodes, okay, name node will have the latest state of snapshot of all the data nodes, right? So what are the data nodes available? What is the data available on this? Everything will be available on the name node here. So name node will decide based on where this client is, what is the size of the entire file, okay, and what is the capacity available on each of the data nodes, and also your rack awareness will come into picture. You remember we talked about rack awareness the other day. So that rack awareness will also come into picture, just to make sure that none of the nodes are overburdened or overloaded with any of the data. Does it answer your question, Jay? Okay, perfect. So let's move forward. Let's see some Hadoop commands. I think I showed you this the other day, but some of the Hadoop commands you can typically use your HDFS, right? So since you are using a Hadoop, you'll be using HDFS 2. So let's quickly come here. Now there are 3 modes of installation. I think I'm not talked about the modes of installation, right? So modes of installation is standalone installation. Then there is first is a standalone installation or a single node. Okay. Then there is a pseudo distributed node of installation where all the processes will be running on the same machine. So in this case, the one I have right now is the pseudo mode of installation. Okay. So if I do sudo su, I do JPS. User Java JPK then JPS. So I mean this is the one I'm using is a quick start VM where I have everything running. So in this machine I have a job tracker, I have a resource manager, I have a data node, okay, I have a node manager, name node, task tracker, everything running on a single machine, and I have a secondary name node. So when you have everything running on a single machine, you are calling it as a pseudo distributed mode of cluster. Because typically when you say a distributed cluster, you need to have daemons running on multiple machines, right? Your name node, right, your master should be running on one machine, then your slave should be running on a different machines. So master slave architecture, but in this case I am having everything running on a single machine, so that's why you call it as a pseudo distributed. Now the next mode of installation is a fully distributed mode. That is what you typically be working on in your enterprises or in your organization, and that is what you would be installing. Okay, so you'd be installing, or I mean the way you work with your enterprise cluster, it will be a fully distributed cluster. Now the reason I went into I went into a root user. I think you know the differences, right? So this is okay. This is your dollar symbol will indicate it's a non-root ID, and your hash symbol will indicate it's a root ID. Okay, so I'm logged in as a root user ID so that I can list out all the processes which are running. Because basically this ID which I'm logged in right now is a Cloudera ID. So if I do a JPS here, it will not list me. It just says one runjar is running. So I don't know what runjar. It might be some application I just launched here. Okay, one JVM is running. That's all. So some of the commands. Some of the commands are ls test. So I have a test.txt. Something called file is here. Test.txt is the test file. Did we execute a MapReduce program, guys? I don't think we have done a MapReduce program execution, right? A sample execution. Okay, so let's say I have a sample file. Okay, let's see how you write typically how the MapReduce program will be submitted on your cluster. I'm already here in this location. Open this test.txt file. So this is a test file. Just say to test. I would say MapReduce. Okay. So I have only one line. I'm pasting it 5 times. Just trying to make sure I have 5 lines. 1, 2, 3, 4, 5 lines. Right. I have 5 lines here. HDFS DFS-ls. Okay, I have some stuff available in here. Let me clean up my HDFS directory so that I can delete everything. We'll start with fresh. HDFS DFS-rm-r. Okay, hyphen skip trash. Okay, you know what is trash is? Trash, I think we not talked about, right? So trash. Let's say I'm deleting this directory. Okay, there is a Uzi project available already here. I'm deleting this directory right now. Copy and paste it here. See, what will happen here is when you delete any directory or a file or folder, okay, there is a option to send this into a recycle bin. Similar to your Windows, okay, where you have a recycle bin. The advantage of recycle bin is you can retrieve, you can recover the data anytime you want to. Okay, by mistake you would have deleted a folder or a file. Now, if you, I mean, in Linux, if you delete a file, what will happen? It is gone forever, right? You cannot recover it at any cost. So maybe Windows has got that ability to recover, where if you abruptly close or if your machine crashes, you can recover. But with Linux, that ability is not there. If you lose a file, if you delete a file, then it's gone. You cannot retrieve it. So situations may arise where, and the same thing can be applied for your Linux also. For your HDFS also. So you delete a file. Okay, when you delete a file, you will not have the ability to recover. So to avoid that situation where inadvertently, if you are deleting any file, they have implemented a trash. Okay, that will move into trash. So this is going into my trash. So where exactly it is going? If I do my TFS command here, I'm doing an ls. So this Uzi project is deleted. Okay, this is in fact a folder here. This Uzi project has been deleted. Now, where will this be available if I want to retrieve? You also see something as a .trash. Okay, for each user, there will be a trash created. HDFS dfs-ls .trash. Or typically you can also use HDFS dfs-ls-r. Okay, you can do a recursive listing of trash. So when I do a recursive listing of trash, so I have a trash folder. Within that I have a current, okay, directory. Within that I have the user created. Now within that I have a Cloudera user, Cloudera user directory created. And in that Cloudera, I have the Uzi project. Whatever I have deleted, it went and it came inside here. And whatever is there in this Uzi project folder is available now. Okay, so you can look into this. So this is, now you understand where it goes. Give current, then give user, then Cloudera. Okay, and give Uzi project. So this is where you can recover it. Now you want to, you say you have, by mistake you have deleted this folder, you want to recover it, you can always recover it. How do you do that? Your HDFS commands, right? DFS. So typically you want to upload a file, what do? You put the file, right? You upload a file, okay, move from local source to destination. You want to get a file, you use your get command, use your get command, then you copy to local, okay, copy to local, move to local. So these are the commands which you can use to retrieve this directory. Okay, so always remember that this is available. So, but then your administrator should have configured the trash, right? Now I want to delete everything available in this location. Okay, because I want to load this test.txt here. I want to clean up my directory space. So what I will do, HDFS dfs-rm-r. Okay, I can do rm-r and hit enter. It is giving an error message because you also have. Okay, I can give rm-r and give the option skip trash. Skip trash and give the source. What is that you want to delete? Uzi is already deleted, right? So okay, it is Eclipse. What happened? 1 second. So HDFS dfs-ls. Okay, so Hadoop, so HDFS dfs-rm-r. So typically you can give user Cloudera, right? So user Cloudera and give the option hyphen skip trash. I don't want to send this into my recycle bin. Okay. Why is it? Oh, I'm doing RM hyphen RF. Sorry guys, it is RF. Okay. So it says permission denied right now because this user Cloudera I'm doing on at one level above. So let's see what these permissions are also. HDFS DFS -ls /user /Cloudera. So this is what I'm trying to delete. But typically, if this permissions issue comes up, you can see here this user is owned by. Okay, user is it says. So you can only write into it. Okay, you will not be able to delete this directory, right? The user. So the user is what you need to look into, right? So if we say HDFS DFS -ls of /, so the permissions on user are owned by HDFS. So you cannot, I mean, though you have a directory, you cannot delete your directory. So to avoid that, what you can do, you can use as sudo. Either you can change the permissions, but don't change the permissions. Just use sudo su. This will log you in as user ID root. From here, because I have not set the password for HDFS, so I'm just logging as HDFS. Okay, if I do a ID, so I'm logged in as HDFS. Now HDFS DFS -RM -R skip trash and say user Cloudera. Whatever is there in this directory will be deleted. Okay, it just says deleted this directory. Okay, so this is how you can use your commands to delete. Now exit out of this, come back as exit out of root user, come back as user ID Cloudera. So you have your file here. So if I say Hadoop, HDFS DFS -ls. Okay, so your directory is deleted, right? So you can create the directory now. So HDFS DFS -, I'm not sure if I have the permissions, mkdir, I would say, so user / I will not have the permissions. So it says permission denied. So use the same thing. Sudo su. Just bear with me, guys, because I don't have the password set here. So su into HDFS. Now HDFS DFS -mkdir. Create a directory. User. Okay. User Cloudera. Okay. Now HDFS DFS -ls of user. You have the Cloudera directory created, but this is owned by HDFS and supergroup, right? So change the permissions here because your Cloudera should be able to write inside this Cloudera. So see, how do you do that? HDFS DFS -ch own. Okay, so ch own Cloudera. So you will see that this is exactly your Linux commands. Cloudera for this particular user / Cloudera. So you have set the user directory for your Cloudera. Now instead of exiting this, let me open one more shell script, one more terminal here. This I'm logged in as user ID Cloudera. Okay, so cd home Cloudera. I have the file under desktop, right? So test.txt is in my desktop. Now let's do HDFS DFS -ls. Okay. So nothing is there right now in your directory. Everything has been deleted, right? So HDFS DFS -ls of /user. If you do this, you will have Cloudera showed up, and within that, if you say Cloudera, you don't have anything in there, right? Nothing is there right now. Let's say bash here. Okay, let me open one more. This is getting confusing for you guys. So let me open a new terminal. So this should be better. Let me close this. So in this instance, I logged in as a HDFS ID, and in this instance, I'm logged in as user ID, Cloudera. So HDFS DFS-ls. It just comes out saying there is nothing is there in your directory, right? So let's upload this file here. HDFS DFS-put your test.txt into your home directory. Now if I do HDFS DFS-ls, it is telling my test.txt is there. Now you can play around with your HDFS. Say I want to open the file, I say on my Linux file system, I type in cat of test.txt. Right? I'm opening this and sending the output into my standard output. Similarly, you also have a Linux command. You also have a similar HDFS command, HDFS DFS-cat, okay, test.txt. So what is the difference between these two commands, guys? Where is this running and where is this running? Can one of you quickly tell me what is the difference between these two? Now this is actually running on your local file system, right? This is running on my local file system, and this command is running on my HDFS file system. So that is your difference. Primary difference, very, very important difference you need to understand. A lot of people get confused here only. Okay, my first command is running on my local file system, and the second one is running on my HDFS. Okay, this runs on my HDFS. Now this is very important. Some of the commands you can play around with here is some of the commands. I want to see where this file is actually located. Okay, so where this file is located, I want to figure out. So you have an utility called as HDFS DFS-fsck. Okay, fsck on slash, like your it is HDFS fsck on your slash directory. So this will tell me, okay, it's failed. My fsck, normally fsck is what? fsck is a file system consistency check which you run on your Windows or on your Linux, which will try to repair. Okay, so you'll send in various options to repair your file system. So now my file system, this is not healthy. It is saying it's failed. So there is some reason here. Okay, there's some issue here. But if I want to see where my actual file is located, okay, you can actually look into -files. Okay, it will give you the list of files available. Okay, the list of files available. So what I did was I have uploaded a file. Okay, I think the problem here is because the user is not able to run execute because it does not have the permissions. So HDFS fsck on your root file system. Okay, now see the difference here. Now here I ran with the user ID Cloudera. It does not have permissions on to read into its location because it's saying user does not have permissions on the temp directory. Now I ran with user ID HDFS because HDFS is a super group, right? It's a super user, so it will give you the list of everything. And I can also give options. I can send in options to this files. Files will indicate, okay, files will indicate what are the files available, right? So this will give me a list of huge list. So what I can do, I can filter out the data. I want to get only grep for test.txt, right? My test.txt is a file which is available, okay, and it is under-replicated. Under-replicated because target replicas is 3, but it's found only 1 replica, right? The file is currently under-replicated. No replications are there. Now, I can also get the locations of the file. Where I want to see the file is there, but where is this located? The location says it will give you on the server. This is available on. Why it's not giving? 1 second, guys. Hyphen files. I can give hyphen blocks. Typically, you need to run this without the grep here. So you'll get a huge listing here. Let's go slowly here. User, Uzi, share. Your Hive, then let's go a little bit up here. Okay, user cloudera text.txt. There's a file here. Oops, no, sorry guys. This is the command. I ran it here, right? So, hbase temp is all temp. Oops. So this is where the file is here. So this is what my important. This is what my important part is. Okay. So I'm getting the test.txt made up of 190 bytes. Okay, it is indicating under-replicated. Now this important thing is what? This is a block file. Okay, this is a block, and this is a replication, one replication available on this host. Okay, so with this information, you can actually go into this server and see that file. Okay, see the metadata location where you're writing, and then you can open up the file. So, but typically you'll not understand it, right? Because the data nodes know only the block names. They don't know it's a file. There will be multiple blocks, and this is how the data is stored across on your cluster. Now, some of the commands you as an admin will do are DFS admin report. I think I already told you, right? So you do HDFS DFS admin -report. Okay, which will tell you the status of your cluster, the health status of your cluster. What are the nodes available? Total report, configured capacity. This capacity information can be seen from your name node user interface also. If you don't want to log in and run your DFS command, you can actually see this information. Okay, don't want to putty into it and run your command, you can actually look into this information here. So this is what it is telling me, that I have one live data node. Okay, it's also saying the same thing here. I have one live data node here. Okay, so yeah, so there are a lot of commands here. Okay, on HDFS. So let me not go to MapReduce today. Let me finish. Just give you try to explore these HDFS commands. So since you're new to Hadoop, so you just type HDFS. This will give you what are all the options you can send in. So here is what I have sent. My DFS admin I showed you, your FSCK, right? Your format we are done, right? Name node format. Now your file system, DFS file, so you run a file system, HDFS, DFS. Enter HDFS, DFS, and you have, okay, you have all the information here, right? So how you can use each of the commands. So try to set up your cluster and then try to go through each of the commands.